Hello engineers or product designers who want to learn a bit about electronics. I'm going to look at Circuit Wizard again, and instead of using the product design with the pretty pictures and the chip, the project boards that you use and plug in simple components like LEDs and switches, as with the traffic light, we're going to do a bit more circuit theory, electronic theory, and cover something that comes up time and time again in exams. It's a useful application as well. A lot of you might want to kind of look into it for an NEA. So what we're going to cover is we're going to use circuit diagram, because that will just use schematic components, far more kind of theoretical based, but you can do a lot more advanced electronics with that. So we'll go there. As with the product design simple thing, we're going to need to connect up a circuit with power supply and etc. So I'll go there and I'll just use a battery here, 5-volt battery. Now obviously I can draw a circuit. I can't actually finish this line, and I can only connect it up to something else, and I've only got a battery here, so I'll have to make a short circuit here to connect it. So best thing to do is, rather than burn out a battery like that, just get all your components that you're wanting to connect together in first. Now what we're going to do here is control an analog input into a microcontroller, so a PIC chip. Now it's the kind of thing that you'll find in exams, in the textbook here. You'll notice on page 258, 259, here's an example of what we do. So we've got a light dependent resistor here. So it's sensing the amount of light coming into something or other, like an automatic street light or whatever. And then when it decides that a certain analog voltage has gone into here, it will do something, you know, depending on what the program has told it to do. Now this setup here is commonly used in electronics, and it's what's called a potential divider or a voltage divider. What happens here, so we've got the 5 volts of the system and the 0 volts ground, which is often a way of drawing it. Instead of using a battery here, you use a voltage rail. So you draw the 5 volts at the top and the 0 volts at the bottom, and then everything. It's just a common schematic way of drawing stuff. Just so you know as well, keep digressing, but it's relevant. When you're drawing in a chip as well, you can either draw it in this schematic way, where you've got the 5 volts, the voltage input at the top and the ground at the bottom, or you can draw it as is, so with the pins in exactly the same place as a real life chip. This is possibly more logical, but it can make a rectangle of a circuit. So quite often engineers will actually do these schematic chips instead, which is slightly easier to lay out. In this case, we're just going to use a Genie 8 with one input, because yeah, we don't need all these unnecessary legs. So yeah, back to the textbook. You'll notice here, that's what we've got here, the 5-volt input rail here and the 0 volts here, and then the input going in here. Now what happens here is we've got 2 resistors in series. These are sharing this potential difference. So the voltage from 5 volts drop down depending on how much resistance this is, and then drops down to 0 from here. So it means if these are the same resistance, they are consuming the same amount of energy. If this is 10k, and that voltage there is going to be at 5 volts as it goes in. Similarly, if there's no resistance, 2.5 volts. So it's going to be half of this 5-volt voltage. So if this has got no resistance, this is going to be 5 volts. So the voltage is just going to go straight in, consumed, uninhibited like that, and then this is going to be showing the full resistance from 5 to 0 volts. Okay, so equal resistance, it shares this voltage. If this is like 1,000 ohms and this is 2,000 ohms, then this is going to be at 2/3 of the voltage, whatever, 3 and something or other volts. Okay, and that's it. That's pretty much it. So we'll just reconstruct a circuit like that, play around with it. We'll do some questions, show you a simple formula, and that will just about cover this video. So in this case, we're going to draw the wires. Remember the 5 volts here, the 0 volts here, and then let's draw some resistors. Now, in this case, I'm going to just have a fixed resistor here and a variable resistor here. We can also draw LDRs and some sensors. You'll notice we've got LDR there and a thermistor here. There's a few. They're not all changing resistor, variable resistor type sensors. You'll notice also on the textbook, on the page before, we've got a list of sensors here. And the ones that change the resistance are going to use a potential divider to be able to kind of control an input voltage. You might have a sensor that's got a minuscule voltage just generated, something like a thermocouple, which is another heat sensor. Just when it gets really, really hot, you get tiny, tiny voltages out of a twisted wire of different types of metals. And in that case, you might want to use an amplifier or 2 amplifiers or 2 transistors in series just to amplify that circuit. But we'll cover that in a different video. So yeah, all sorts of things. By the way, there is quite a good little analogy. It's quite handy to remember which way round these two work, because these are the most common types of sensors you'll see. So light and temperature. My weird little analogy that makes me remember which way round they go is think of chocolate. So when on a hot sunny day, chocolate melts, and when chocolate melts it flows. So think of a chocolate as being like that variable resistor, the thermistor. When it gets hot or when it gets bright, the current flows, so the resistance has dropped. So basically when these sense light, the resistance lowers. Just an easy way of getting it round. And so if you're drawing this potential divider, it depends which way round you have this light sensor. So I'll do that as an example just so that we'll keep that relevant. So we'll go to those sensors and we'll just put an LDR there. Okay, and you might even have, this is a variable resistor, but you might also have an actual variable resistor here just so you can calibrate. You can tune this to kind of get the right voltage to switch this on. But obviously if this is at the top, when it gets bright, the resistance lowers, so when it gets bright, this voltage is higher. Whereas if it's at the bottom and the fixed resistor or the calibration resistor is the other way around, when it is dark, this voltage gets higher. Okay, so depending on which way round you do it. Right, we're going to put that there. Sometimes as well in textbooks and exam questions, you might notice in the textbook we haven't got another resistor there, but it depends. You might actually want to just protect or kind of reduce this input if it's a sensitive little chip. I believe in the exam question we're looking at, no, that's fine. So yeah, don't worry about that too much, but some examples you might even see another resistor there. Okay, so what are we going to see here? Well, in fact, I've just demonstrated explain the variable resistor, how much light it is, but just for simplicity's sake I'll keep it just as a variable resistor so we can play around and see what we're doing. So in this case we're going to have, if I double click on it, I'm going to put a 2k resistor in. That means when it's just set halfway it's going to be the same resistance as here, so this 5 volts drops down to 2.5 volts and down to 0, those two sharing that voltage. So when we press play, like I said before, if you're future-proofing a project file that you want to put a circuit in, a flowchart in later, just do that. Do a dummy blank flowchart like that, and then it will work. You'll also, in real life, for this to work, you want to connect that pin where it says R to plus volts. That's a reset pin. It will just make the whole thing run. If that's not connected, it will constantly reset. So if you want an actual switch to reset your chip, you put a push to break switch in there, and when you push it, you reset the chip. So press play, it should work. don't see anything happening, but if you hold the mouse over here, you'll notice the voltage. Okay, so we can see that's proven that theory. Those two 1K resistors are sharing that 5 volts, and halfway through you're getting the half of the voltage, 2.5. So what happens if I have no voltage here? Well, let's turn it down to 0, like that, and you'll see this has 5 volts. Okay, if we turn it up to 2000, so this is most of the resistance, and this is 2/3 of the resistance, and this is 1/3 of the resistance. What we're going to have here, I would guess, it's going to be 1/3 of it. So most of that drop is happening through here, and then 1/3 of it is going through there. So you can see a relation here, and it's quite a simple relation, but to actually kind of break it down into a mathematical formula, it's a little bit long-winded, but we got this formula here. R2 over R1 plus R2 is the ratio, basically. So it's just it's that fraction of the two resistors together. Just got to remember which way round R1 and R2 are drawn though as well. You'll notice in the exam it's actually given it, that formula is given to you, and you're actually told which way R1 and R2 is as well. So makes life a little bit easier sometimes, but you still need to know what to do with that. And that's pretty much it. So a simple kind of circuit design here that you can test. You can also put, rather than holding the mouse over, you can put test instruments in here. So we could put a voltmeter here across this. So connect it from, so this is the same as a 0-volt rail, and this is the 5-volt rail. We can see what that voltage is compared to 0. So you'll see whenever you play around with this, you can do it live and it will just change what the voltage is. Okay, so a really basic introduction to how to control a sensor, one of many different types of sensors, into a PIC chip. Now if you were going back to the flowchart, if we are to play around with that, what we've got here, instead of looking at a digital question, digital input read, we look at the analog input read here. Now what's happening here, instead of saying check the voltage, what's happened in the chip is something called an analog to digital conversion, ADC. You'll quite often see that in electronics. And what that's done is split that 0 to 5 volts into the range of the digital range. So in this case, however many bits it is, it's 256 steps. So it will measure that 0 to 5 volts in that range. And you can just kind of calibrate the range here. So when it's within that range, you can say switch the street lights on or whatever. Play around with it, have a little go yourself. Just it's a good little exercise to familiarise yourself with circuit wizard. It's a really nice way of kind of demonstrating theory, testing your own circuit designs, and just kind of underpinning your example maths knowledge. So in this June 2019 question paper, you'll notice question 3, we've got, I think it is a street light or something, I believe, yeah. And it will just put your knowledge of this potential divider circuit to the test. So in this case, we are given the voltage in, and we're looking to see what resistance this will be when we get 3.75 volts. So it's kind of reverse engineering this. Now you might find some of you can kind of work out that ratio quite easily to work out what R1 is to get that voltage drop. If you use this formula on your workings and just kind of plug in the numbers and rearrange it, I find sometimes, especially when I'm under stress, if you're doing algebra, it can quite easily be a confusion. Whereas if you just kind of step by step rearrange this formula, as I've done here, put in all the numbers, swap the, in this case we're obviously we're looking at dividing those two to get that ratio, and then those combination. So it's a long-winded way. It takes a bit of time. If you've got the time and you're not under stress, you can do it this way. Then if you get a mistake at some point, the examiner is going to award you marks for just getting the same, getting a nice procedure across like that. And you can see that resistance is 2 kilo ohms if you do it that way. Okay, so simple, straightforward way of just using that formula. I say simple, straightforward. Takes a bit longer to do it than just working out the ratio. But it's a good practice in exam, because if you make a mistake, or if you're just really, really slapdash and you just put the answer down, some examiners can be really kind of tight, and they'll penalise you if you don't do the step-by-step thing like that. All right, so hopefully that'll explain potential dividers to you in a better way. Have a little play with Circuit Wizard. It's a nice little program just to kind of play around with ideas and whatnot. And then, yeah, hopefully that will help you. Okay, thank you very much.